The last lesson in Unit 3 is talking about linear inequalities in two variables and how to graph them. So far we've only focused on equations of lines in two variables and graphing them, talking about the slope, parallel, perpendicular. Now we're going to focus on inequalities. So first thing is a definition here. A linear inequality in two variables is any expression that can be put in the form ax plus by is less than c, where a, b, and c are real numbers and a and b are not equal to 0. So there are some examples here. 2x plus 3y is less than 6. Y is less than or equal to 2x plus 1. X minus y is less than or equal to 0. So those are just a couple examples. Another important thing is how to graph these. So there's a couple steps. The first step is graph the inequality as if it was an equation with an equal sign. So we're going to kind of ignore the inequality sign and just pretend it has an equal sign and go ahead and graph using one of the methods that we talked about in the first couple of lessons. And then if the sign is a less than or greater than sign, you're going to use a dotted line. So that means the graph will not be solid for the line because it's strictly less than or strictly greater than. If the sign is less than or equal to or greater than or equal to, then you're actually going to be using a solid line, which is what we normally do when it's an equation, because it's representing all of the points on the line are solutions, where when it's strictly less than or greater than, the points that lie on the line are not part of the solution. Once we've graphed the line, then we're going to pick a point anywhere on the graph other than on the line, and we're going to plug it into the x and y values. You will then simplify. If the statement is a true statement, then you're going to shade wherever the point is. If the statement is false, then you'll shade away from the point. So let's look at an example. Graph the solution set for x plus y is less than or equal to 4. So the first thing I'm going to do, let me just rewrite it. We're going to get this into y equals mx plus b form. Remember, whenever you want to graph a line, you want to get it into y equals mx plus b form so that you can figure out the slope and the y-intercept. So I'm going to subtract x from both sides. So I have y is less than or equal to minus x plus 4. When we graph this, it's up to you if you want to use a table of values and plot points, which is what we did in the first lesson. We also did a lesson on using just finding the x and y intercepts and graphing that way. And then we also did a lesson where we use the slope and the y-intercept, and then we plot the y-intercept and then count rise over run. That's probably the most common way, so that's the way I'm going to do in this video. So the first thing I'm going to do is I'm going to find the slope. Remember, the slope is always the number in front of x, so it's a -1, which is really like thinking of it as -1 over 1, because if I divide by 1, it won't change. Since this is a negative, that means I'm going to be going down 1, and I'll always start by going to the right. So my starting point, or my y-intercept, is going to be +4. So what I'm going to do is I'm going to start up at 4, and I'm going to go down 1 to the right 1. Down 1, right 1, down 1, right 1, down 1, right 1. You keep doing it, and then you can backtrack and go the other way. So it'd be left 1, up 1, or up 1, left 1. And then I look at my sign. So I look at my inequality sign. My inequality sign is saying y is less than or equal to. So since it has the less than bar, that means it's going to be a solid line. So you're going to go ahead and you're going to graph a solid line. So a solid line through these points. We can go ahead and we can put arrows on them. And then the next thing is going to be the shading. So if this said y equals -x plus 4, I would label my line and I'd be done. However, this is an inequality. So now what you're going to do is you're going to pick any point and you're going to test a point. So when I test a point, if possible, I like to choose the point 0, 0 to test because it's going to be the easiest to calculate. So if you look, the point 0, 0 is the origin, is not on the line, so that means I can use that to test. And if it works in my inequality, it makes a true statement, I'm going to shade over 0, 0 because then that means I'll include it. If it doesn't work, I'll shade on the opposite side of the line away from 0, 0 because it does not include 0, 0 in part of the solution. So let's go ahead and we're going to test 0, 0 into our inequality. So my original inequality was x plus y less than or equal to 4. So when I plug in, I have 0 for x, 0 for y, is less than or equal to 4. I'm trying to see, is this really a true statement, which is why I put the question mark above the sign. So 0 is less than or equal to 4. That is a true statement. So that means I want to include 0, 0 in my solution. You want that point to be in your solution, so that means your shading is going to go over 0, 0. So then to label my graph, I would put the equation. And that's it. So that shows any point that lies on the left side of this line is a solution to this inequality. So any point would work. Also keep in mind, when you look back at the y less than or equal to negative x plus 4, y is any number less than or equal to the equation. So if you think of it that way, that means your shading has to go below the line because y is less than the equation of the line. So that's another way to think of it, but testing a point will always work if you're not sure on which direction to shade. So let's look at a couple more. So example 2, graph the solution set for y less than 2x minus 3. So I'm looking at y less than 2x minus 3. So the first thing I'm going to do is get it into y equals form, which it already is. And then what I'm going to do is I'm going to pick out the slope, which is 2. It's a positive 2, so it's like saying 2 over 1. So it's going to be up 2, right 1. Y-intercept is negative 3. So that'll be my starting point. So I'm going to start down at negative 3, and I'm going to rise up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then I'm going to backtrack. I'm going to go the other way. So down 2, left 1. Now, before I connect my line, check the sign. The sign is a strictly less than sign, not equal to. So this means you're going to use a dotted line, because if you plug in any point on this line, it will not work in this equation. This equation of the line that I just graphed, all those coordinates, is just going to kind of work as like a boundary so that I know which side to shade on. It's like a boundary for my shading. So think about it. If you take any point and you plug it in that's on this line, it will not satisfy this. It'll actually make y equal 2x minus 3. It won't make y less than. So that's why we use a dotted line. So then we're going to go ahead and we're going to connect those using a dotted line. And then we got to decide on the shading. So the shading part, remember, we're going to test a point. I like to look for the origin. As long as the origin is not on the line, I can use that as a test point. Otherwise, you have to pick a different point. So I'm going to test 0, 0. So my inequality that I'm substituting in for is y less than 2x minus 3. So let's go ahead and plug in. So I have 0 less than 2 times 0 minus 3. This is saying 0 is less than negative 3, which this is not true. So this is false. So that means my shading is going to go the opposite way. So it's going to go away from the origin because the origin does not satisfy the inequality. So what that really means is y, if you look, y are all of the values less than the equation of the line. So it should be shading below the line, which is what I did. So this I would label y less than 2x minus 3. And that's it. So let's look at one last example. And this one we're going to graph the solution set for x less than or equal to 5. So remember, this is going to be a vertical line going through 5. And because of my inequality symbol, since it has the equals bar underneath, it can equal 5, but it can also be less than 5. So for this one, it's going to be a solid line. And I'm going to go to 5. And remember, this is a vertical line because x is always going to equal 5, but y is going to change. If you're thinking of it as a table, x is always 5. Y can be any number you want. -1, -5, 0, 2, any number you want. So that means you're going to go over to 5, and we're going to draw a vertical line through 5. So I'm going to go ahead and draw a vertical line through 5. I'm going to put my arrows on there. And it's solid. And then I have to decide which way to shade. So again, if you test a point, you could test, let's say, the origin. So if you test 0, 0, you plug that into x less than or equal to 5, well, the only number that you're really going to plug in is going to be the x value because there's nothing to plug y into. So if you plug in 0, 0 is less than 5 is a true statement. So that means your shading is actually going to go over the origin. So your shading comes to the left, which makes sense. Think about what it really means. It's saying x is less than or equal to 5. That means all the numbers smaller than 5. So you should be shading to the left. So then that's it. You kind of do the same process for, y less than a number, y greater than a number, except for everything would be horizontal.